welcome to my YouTube channel. In this video, we're gonna learn about how to find some special integrations using beta function. So let's begin. So what is this beta function? First we will see that integral. So the integral is of the form 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. So this value is equal to beta of mn. So here this m and n values are greater than 0 and these are real positive numbers. So now we will see how to use these values in the integrations. Suppose question is given like this: x to the power 8 into 1 minus x to the power 7 dx. Then how to find this one? So if you use the standard formulas to find the integrations, so here see, this is one function, this is second function, so you have to use the integration by parts, that is eyelet rule. Okay, so here we cannot apply the eyelet, but we can consider this function as first function and this function as second function and find the integration. But there is no necessity, as we already know this function is beta mn. So all you have to do is to find the value of m and n. So now compare these two equations. Okay, so now see, at the first place here this value is x to the power 8 and here it is x to the power m minus 1. Then if you compare, here this m minus 1 value is 8 and next term see, here it is 1 minus x to the power 7, and if you compare this with this one, then see, here it is 1 minus x and here is 1 minus x, here the power is 7 and here the power is n minus 1. So from here I can tell that this n minus 1 is 7. So after solving I can find that this m value is, take this one to the right hand side. Similarly here the n value is, take this one to the right hand side. So the m value is 9 and n value is 8. So the value of this integration would be beta m comma n. So m is 9 and n is 8. Okay, so now I got that this value is the beta function. So now how to calculate this beta value? So we can find this beta value using the gamma function. Okay, so what is the relation then? So the relationship between beta function and gamma function is beta mn equal to gamma m into gamma n by gamma m plus n. Okay, so now if I want to find gamma of suppose 4 5, then this would be equal to, just substitute the value. Here the m is 4 and n is 5, so in right hand side also, in place of m use 4 and in place of n use 5. Okay, so now see, what is this value? This is gamma 4 into gamma 5 by gamma 4 plus 5. So now what is this value? This is gamma 4 into gamma 5 by gamma 9. So use the factorial format. So gamma of 4. So what will be the gamma 4 value? It is 4 minus 1 factorial into gamma 5. Similarly, it would be 5 minus 1 factorial divided by gamma of 9. That would be 8, right? So that is 9 minus 1 factorial. And what is the formula here? Now here the formula is gamma of n is equal to n minus 1 factorial. So now let's solve a little bit. This is 3 factorial and this is 4 factorial, and this is 9 minus 1, that is 8 factorial. So you all know the factorial values. So 3 factorial would be 3 into 2 into 1, and 4 factorial would be 4 into 3 into 2 into 1. Then this 8 factorial, it would be 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So now if you want to know about how to find this gamma n value and how to find this factorial value, then you can check my previous video. The link I will share in the description box. Okay, so now let's calculate this one. So just see which terms are common and just take cross. Okay. So here it would be 3 2. Now this 2 will cancel. Here that is 4, here that is 2. Okay, so now this value is 1 by 2 into 7 into 5 into 4. So 2 into 7 into 5 into 4. So whatever may be this value, you use the calculator and find this one. Okay, so as there was transformation in gamma function, similarly in beta functions also there are transformations. So we will see what other form does this beta function have. Okay, so this transformation means another formats. Okay, so we will see what other formats are there. So like in gamma function, here also we'll have to make certain substitutions. Okay, so the first substitution comes, first write down the function. It is beta mn 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx. So now to transform, let us put x equal to 1 by 1 plus y. Okay, so from this substitution we'll first find out the value of dx. Okay, x value is known, dx value we have to find, and another thing is that find the limiting value. Okay, and here see the transformation is changing from x to y. Okay, so this integration is changing from x to y, so all these things should be in terms of y only. Okay, this term would be dx by dy, and the right hand side term would be d by dy of 1 by 1 plus y. And now how to derive this thing? So if you want to use the u by v formula, then it is good, or else you can take this 1 plus y to the numerator part and then find the derivative. Okay, so I suggest you to use the standard formula. Okay, so we will use the u by v format. So what is the u by v format? It tells that derivative of u by v, it is v into u derivative minus u into v derivative by v square. So what is u here? Here the u is 1 for this, and the v is 1 plus y. So let's substitute all these things here. Okay, so the first one is v into u derivative. Okay, so v is 1 plus y into derivative of u. So the derivative is with respect to y only. Then minus u is 1 into derivative of v, which is 1 plus y, divided by b square. B is 1 plus y. So now this term became dx by dy. Now this term is 1 plus y. Then derivative of 1 with respect to y, it is 0. Then how to find derivative d by d of 1 plus y? Use the linearity principle. It will go towards here and it will go towards here. So by linearity principle, this term would be this much. plus d by dy of y. Then here this term is 1 plus y whole square. Now this term is dx by dy. Now this term 1 plus y into 0, this term is 0, so no need to write this one. So here it is only minus 1 into derivative of 1 with respect to y, so this term is 0. Okay, so 0 plus here this term is d by dy of y, it is 1 by 1 plus y square. So now say this is 0 plus 1, that is 1, and minus 1, it is minus 1 by 1 plus y square. Okay, so from here you can write that this dx is equal to dy. Take this dy to the right hand side, it would be minus dy by 1 plus y whole square. Okay, so now see what transformations do we got. First transformation is x equal to 1 by 1 plus y, we got this thing. Now dx we already find out. Okay, then another term is here, see this is 1 minus x and the limit part. Okay, so then what will be 1 minus x? Now as x is 1 by 1 plus y, then 1 minus x would be 1 minus, in place of x write the value. Okay, so x value is 1 plus y. Now rationalize this term, it would be 1 plus y minus 1 by 1 plus y. That means this 1 minus x would be, just see this one is 1 plus y minus 1, so here that is plus 1, here that is minus 1, both will cancel out, and this value would be 1 y by 1 plus y. Okay, so the next substitution is for the limits. Okay, here the limits of x are from 0 to 1, so let's take the lower limit first. So when x is 0, what will be the value of y? Okay, so substitute the values here. Okay, so from here as x is 0, it is 1 by 1 plus y. So from this we can conclude that, take this 1 plus y to the left hand side. Okay, so this is 1 plus y equal to 1 by 0. From here take this one to the right hand side, so it is 1 by 0 minus 1. As 1 by 0 is infinite and it is infinite minus 1, it would be infinite. Okay, similarly the low upper limit is x equal to 1, so I will again use the same equation. So on the left hand side it is 1 and it is 1 plus y. Now take this 1 plus y to the left hand side, so it is 1 plus y equal to 1. So from here we can tell that y value is, take this one to the right hand side, it is 1 minus 1, that is 0. So now I got the lower limit and upper limit accordingly to the y. So now our integration is changed to, see first comes the limit and now this limit is for y. So see what is the low limit of y. So the low limit of y is infinite and upper limit is 0. Now let's see the next term. Next term is x to the power m minus 1. So in place of x I will write 1 by 1 plus y. So this one is 1 by 1 plus y to the power m into the next term. What is the next term here? Next term is 1 minus x. So we have already found out this one. So what is the 1 minus x? 1 minus x is y by 1 plus y. So it is y by 1 plus y into the power n into dx, right? So what is the value of dx? We already found out this one. Dx is minus dy by 1 plus y whole square. So this one is minus dy by 1 plus y square. So now let's take all the values of 1 plus y at one place. See here there is 1 plus y, here there is 1 plus y, Here also there is 1 plus y. Okay, and now this value is m minus 1, right? So take the 1 by y common in all the things. It would be 1 by 1 plus y to the power m minus 1, right? The power is splitted to both numerator and denominator, and in numerator it is 1 to the power m minus 1, so it would be 1 only. Then this term is take by splitting this power, it would be y to the power n minus 1 by 1 plus y to the power n minus 1. And here also there is a bracket, and here the minus sign will, let's take out. Okay, or else we can use here also, let it be. Then this term is 1 plus y whole square. Okay, so now see, to I can take this minus sign to outside of the limit of integration, or else here I am using the property that if this minus sign is here, then the limits will be interchanged. Okay, so that would be better. So I am changing this minus sign. Okay, so I am taking this minus sign to the limits. Okay, so the limits will be interchanged, and this minus dy would be plus dy. And in the next step we are gonna add up this powers of 1 plus y. Okay, as this is same, so the powers will add up, and this term would be y to the power n minus 1 dy. Okay, divided by 1 plus y, this m minus 1 plus n minus 1 plus 2. Now say this is a minus 1, this is plus 1, so sorry, minus 1 is minus 2, and this is plus 2, so both will cancel out, and now the rest term will be okay. Before that, whatever the properties we have used here, I'm writing here. So one property is that if the limit is from a to b minus dx, then I can take this to the limits, and it will be changed as b to a dx. And another property which I used for this 1 plus y here is that if base is same, then the powers will add up. Okay, see here the base was same at one place. Here it was 1 plus y, here was also 1 plus y, here was also 1 plus y, so the base was same, so I can add up the power. So I added m minus 1 plus n minus 1 plus 2. So these are the formulas I have used. Now let's solve this thing. It would be 0 to infinite, it is y to the power n minus 1 dy, divided by this term is 1 plus y m plus n. So this is the next type of integral formula for beta mn. Okay, so question will come accordingly. Suppose the question may ask that as this function is from 0 to infinite, and see there is no e terms here, so it is not a gamma function integration. Okay, instead it is a beta function integration, but you don't know how this 1 plus y goes to the upside. Okay, so if you remember this formula, then from here you can see that I can take this 1 plus y to the power m plus 1 to the upside, so it would be 1 plus y to the power minus m plus n, right? Mhm. So in that way, I take this to the upside. So now compare these both types of integration. Here it is y to the power 8. Here it is y to the power n minus 1. So here this 8 is equal to n minus 1. So the n value will take this minus 1 to the left hand side, and would be 8 plus 1, that is 9. Similarly, compare this term and this term. So 1 plus y and 1 plus y is common. Here next the term is minus 12, and in the right hand side it is the power is minus m plus n, so minus minus will cancel out, and now this m plus n is 12, and we already found the n value, which is 9, so m plus 9 is 12. So here the m value would be, take this 9 to the left hand side, is 12 minus 1, that is m equal to 3. So as I found the m value and I found the n value, so the answer will be how much? It is beta mn, right? So the answer is beta 3 comma 9. Okay, now you have to use the gamma function to find out this one. Okay, so what is the gamma function? Now as we know, beta mn is equal to gamma m. Okay, so at place of m there is 3, then it is into gamma n, so n is 9 by gamma m plus n, that is 3 plus 9. Okay, sure. You have to calculate this one. Okay, using the formula. Okay, so here the formula is beta mn equal to gamma m into gamma n by gamma m plus n. Okay, so here you have to calculate this value also. It is gamma 3 into gamma 9 by gamma 12. Okay, and you have to find out this value also. Okay, so what will be gamma 3? Gamma 3 is 2 factorial, then gamma 9 is 8 factorial divided by gamma 12, which is 11 factorial. Okay, so here the formula is gamma of n, which is n minus 1 factorial. So wherever there was n, I have written n minus 1 factorial. So see, here it is gamma 3, then this value is 3 minus 1, 2 factorial. Similarly, gamma 9 is 9 minus 1, that is 8 factorial. Similarly, gamma 12 is 12 minus 1, that is 11 factorial. Then calculate this one and write the final answer. Okay, it is 876 3 2 1. This is 11 10 9 8 7 6 5. Now see here, up to this much term, here it is common, so both these terms will cancel out. Only this 2 into 1 by 11 into 10 into 9 will left. So from here also I can write this, so it will be 1 by 11 into 45. So whatever is the answer, you have to write. Okay, so moving on to next type of transformation, we will see the next type, which is first writing the general formula. It is m minus 1 into 1 minus x to the power n minus 1 dx. Here the next substitution comes, that put x equal to sine square theta. Okay, so now let's see what will be the value. So first thing is we have to change this limit. Okay, then we have to find this 1 by x also, then we have to find this dx also. Okay, so let's first find out this dx value. So for finding dx, we have to differentiate both sides with respect to theta. Okay, as if you try to derive with respect to x, then you may get confused. So it is better to do with respect to theta. Then this would be dx by d theta, that is d of sine square theta by d theta. Now let's see the left hand term. It is dx by d theta, and the right hand side, see, this is sine square theta. Okay, so you have to use the chain rule. Okay, so by using the chain rule, it would be 2 sine theta. Okay, first derive this power, which is sine square theta. So the derivative is 2 sine theta. Then again the derivative of sine theta, which is cos theta. Okay, so if you want to know about this chain rule, then I have already uploaded the video how to find derivatives. You may go to that video and check this one. Then from here, the dx value is, take this d theta to the right hand side, it would be 2 sine theta into cos theta d theta, right? So I got the substitution for dx. Next I will go for this 1 minus x. So now what will be the value of 1 minus x? Now as x is how much? X is sine square theta, right? So 1 minus x would be, see from here, x is sine square theta, so 1 minus x would be 1 minus sine square theta. So we all know 1 minus sine square theta is cos square theta. Okay, so the next thing comes that we have to change this limit of integration. So now see, when x is, first take the lower limit 0, then substitute here x is 0, so our sine square theta would be 0. That implies this sine theta would be 0, and when this sine theta value would be equal to 0, now it is only possible when this value is 0. Okay, so from here we got that this theta is equal to 0. Similarly, next take the upper limit is 1, so when this x is 1, I will substitute the values here, so it would be sine square theta equal to 1. So next this sine theta would be 1, take the positive value only. Then when the sine theta is equal to 1, we know this value is equal to sine pi by 2. Okay, so from here I got that this theta value is pi by 2. Okay, so now I got the limits also. So now the integration changed. Okay, so now here see this beta mn value, which was originally 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, it will change. Okay, and here the integration is changed from x to theta. Okay, so see what will happen then. First the limit will change, the limit will be of theta. So see what is the limits for theta. The limits of theta are from 0 to pi by 2. Okay, so always take in order. Okay, in which order you are finding. Then x, the value of x is sine square theta to the power m minus 1. Then this 1 minus x value is, already we have find out, it is cos square theta, so it is cos square theta to the power n minus 1 into dx. So what is the value of dx? See, dx is 2 sine theta cos theta d theta, so it is 2 sine theta cos theta d theta. Okay, so now we will see what are the powers. Okay, now see here this 2 is a constant, so it will go outside of the integration. Okay, now see what is the powers. It is sine square theta to the power m minus 1, so it would be sine 2m minus 2 theta. So how did this happen? It is sine square theta whole to the power m minus 1, so this 2 is multiplied with this m minus 1, so it would be 2 into m, that is 2m, then minus 2 into 1, that is 2. Okay, so the next term is similarly for cos square theta, so the 2 will be multiplied here, then again here, so this power would be cos 2n minus 2 theta. Then the next terms here are sine theta into cos theta d theta. Now see, this is sine theta, this is also sine theta, the powers are different, so here the powers will be added up, so it would be 0 to pi by 2, it is sine 2m minus 2 plus 1 theta, okay, as this power is here 1. Then similarly for cos, it is 2n minus 2 plus 1 into of theta, now d theta. So on solving, this one is 2 times 0 to pi by 2, it is sine 2m minus 1 theta into cos 2n minus 1 theta d theta. So here we got our next formula, okay, which is, this is beta mn is equal to this much, 2 times 0 to pi by 2 and rest terms, okay. Then how to find out this integration? So if you remember this formula, then there is one 2 multiplied here, okay. So if only this integration is given, then this value would be equal to beta mn by 2, right? So here just simply calculate what is the value of this m and n, okay. So by comparing, you can see that at place of 2m minus 1 there is 7 written here, so here our 2m minus 1 is 7. Similarly, if you compare these two terms, here say this is cos 8 theta and here it is cos 2n minus 1 theta. So from here this 2n minus 1 is 8. So from here you can find out m and n value, okay. So this m is 8 by 2, similarly n is 9 by 2, okay. So it is 4. So I can use this value here. Now I can find this value beta mn as this is beta 4 and this is 9 by 2, then divided by 2, okay. Now how to find this one? So this is beta mn. So beta mn formula is gamma of m into gamma of n by gamma of m plus n, that is 4 plus 9 by 2, then again there is one 2 here, okay. So now say this is gamma 4 into gamma 9 by 2. Now this value is here, see this term will go to the downwards, okay. So it will be 2 times gamma 4 plus 9 by 2, it would be 2 into 4, 8 plus 9, 17 by 2. So now to find this gamma 9 by 2, gamma 7 by 2, you can refer the video in which we have already read about how to find this gamma function of 9 by 2 and 17 by 2, okay. So now we will see another property of this beta function, okay. So which is beta mn is equal to beta nm, okay. So you just remember this thing, okay. So this is the transformation which we can get using the first way of transformation, okay. All which, let's see this one. See, this was a first type of transformation, okay. So here in this transformation, if in place of m and n we interchange it to n and m, then this will satisfy, okay. Or else you can see from this second one also, from here also, if you are changing this n and m value, then it would be y to the power m minus 1 by 1 plus y to the power n plus m. So both things are same. So this is a property, you just remember this one. Now another fun fact which usually comes in exam in 8 marks question, which is so that gamma half is root pi. So there is a very interesting formula that we can use this beta function to easily prove this one, okay. So what we have to do now here, to prove this one, we will use that beta function. Okay, so what is the beta function? So beta function is gamma m into gamma n by gamma m plus n, right? So here suppose I will take this m and n as half. Okay, so both are I am taking half, then what will be this value? It would be beta half and half, and right side it is gamma half into gamma half by gamma half plus half. So now see, this value is gamma half and half, and now this value is gamma half whole square, and in the new denominator this value is gamma 1 and half plus 1, that is 1, so gamma 1 is 1, so this value became gamma half whole square. Okay, so if I take this square root in both the sides, suppose I am writing this as this, half whole square. If I take square root in both the sides, then I will get the value of gamma half, right? So for that reason, suppose I'm taking this to the left hand side and right hand side, just interchanging the terms, okay, so that I can calculate this beta half and half. Okay, so now use the value of beta half and half using the elementary formulas, which is 0 to 1 x to the power m minus 1, right? So this is m and this is n, so it would be x to the power m minus 1 into 1 minus x to the power n minus 1, so n is half, so this much. Now see, this one is 0 to 1, this is x to the power minus half, and this term is 1 minus x to the power minus half dx. So both the terms are in negative, so I will take this to the denominator side. Okay, so this term would be 1 by root x, and this term is also in root over. Okay, so how this thing happened, let's see little bit. So this term after going to the denominator, it would be positive, right? Similarly here this term will also go to the denominator and it will be positive, and the formula is here that if it is x to the power minus n, then it can go to the denominator and it would be positive. So now what is this value? X to the power half, it is root x. Similarly 1 minus x to the power half, half meaning is it is root over. Now to find the integration, we have to do substitution method. Okay, so what is the substitution method? See, if I will take x as sine square theta, then this term will be sine theta, and this term will be 1 minus sine square theta, that is cos theta, and the root cos square theta, that is root over is cos theta, then dx. Okay, so all the this integration would be changed to sine and cos, right? So let's substitute this one. So x is sine square theta, then we will differentiate both sides with respect to theta, suppose, then this is dx by d theta, and this is I'm writing directly as we have already solved this thing in the transformation part. Okay, so this is 2 sine theta cos theta, so now this dx is 2 sine theta into cos theta d theta, then x is sine square theta, so next term I want to find this 1 minus x, so it would be 1 minus sine square theta, so it 1 cos square theta. Then next thing is I am changing this integration from x to theta, so the limits will be also changed. So when x is 0, at that time theta would be place these values here. Okay, so here this sine square theta is 0, so that our theta value is 0. You can go back to the video and see how this theta became 0. Similarly, when x is 1, this theta value is pi by 2. Now let's substitute all those things. Okay, so the integration was gamma half whole square, which is equal to the limits. Okay, first the limits will be changed to 0 to pi by 2. Next, this values 1 by root x. So x is sine square theta, then root x would be root over of sine square theta, then it is root over of 1 minus x, so 1 minus x is cos square theta, so this value is cos square theta, then into dx. Okay, so what is the value of dx? So dx is this much. Okay, so use this value here. It is 2 sine theta cos theta d theta. Now see, this value is 0 to pi by 2. Now this term is sine theta, this term is cos theta, this term is 2 sine theta into cos theta d theta. Now see, this term will cancel out. Okay, so only the 2 term left. Okay, and 2 is also a constant, so it will go out of the integration. So here it is 2 times 0 to pi by 2 d theta. Now what will be the integration? Integration of d theta is theta, and the limits are from 0 to pi by 2. So here I will once use the upper limit, then minus the lower limit. So it would be pi by 2 minus 0. So now this value is 2 into pi by 2, which is pi. Okay, so if you remember the left hand side, it is gamma half whole square. Okay, so now I am writing this thing again. It is gamma half whole square is pi. That means I will take square root in both the sides. It would be gamma half equal to root pi. So see, this is an important example which in exams generally comes under 8 mark questions. So you may just practice these questions, and I will provide you more questions regarding this beta function at the end of this video. Hope you enjoyed the videos. If you are having any doubts in solving these practice problems, then please comment on this video. Thanks for watching, and don't forget to like, share and subscribe.